A very good afternoon to all of you present here. In today's topic, we're going to look into another part of or another branch of parallel processing, which we call it as vector processing. Let us now see what is actually vector processing. Vector processing, like any other parallel processing, it processes numerous components all at once. Already, when there are multiple components, and if it has to be, if the components have to be processed, all these can be processed at a higher speed using your vector processing. So what it does is, on every element of the entire vector, it acts upon, and the beauty is it is going to act in parallel. All these processes will happen in just one shot. And these simultaneous operations are actually independent. That is the most important keyword that we need to note here. All of these operations are completely simultaneous, which means it's happening in parallel and they are independent. One processor or one action that is being performed on one element is certainly independent of the other element. Now, working of the vector processing. How does a vector processing work? All right, vector, what do we call it as a vector? Vector is actually an ordered collection of a one-dimensional array. You can imagine a one-dimensional array, which you can either imagine in a row format, like how we have seen on the screen, or it can be in a column format. V1, V2, V3, all these, you can imagine these to be vectors. All right, where each of the V here represents a vector of length n. Suppose you have a row vector of say 100 elements, then this n will range up to 100. All right, as I told you earlier, a column vector is something which is used to represent the data elements in a columnar fashion. All right, where you write in a horizontal, in the vertical format, V1, V2, V3, and it goes on up to the nth element, depending on the length of the vector. Now, how does it work? So one instruction can be used to perform in parallel on several data. Okay. Now, as I told you, you can imagine this to be SIMD in this case. Okay. SIMD means what? Single instruction which is working on multiple data. Say, for example, you want to add 100 elements in 100 different ways. 50 pairs of elements you want to add. All right. Here, what operation is common? Addition is common. But what is different? Each data is different. Say, for example, 1 plus 2, 3 plus 4, 5 plus 6. Like this, you want to add. Instead of adding everything in a serial fashion, you can add everything in a parallel way. Okay. So one instruction can be used to perform parallel operations on several data elements for a processor with multiple ALUs. What is ALU? I hope all of you remember. ALU stands for Arithmetic Logic Unit. Okay. Now, these instructions are called the vector instructions. What was the instruction in the example which I was telling you? It is nothing but the arithmetic operation of adding two numbers. All right. So, when can we, what is the ideal application of a vector processing? So, whenever you have image processing applications or you have graphics rendering, on all those cases, vector processing has been proven to be one of the most efficient method of a parallel processing technique. All right, we will move on to the next slide. Okay, so when you have, this is exactly what I was telling you in the previous slide. When you have two consecutive pair of items which need to be processed in a single cycle, then you can go for vector processing. So look here, the second point. Two pairs of items can be handled concurrently, which means parallelly, in dual vector pipes and dual set of vector functional units. Now, just look at this example. This should definitely give you a clear picture. You have A of 1 to 50, which means you have an array element of 1 to 50 stored in array A. Then you have array element of 1 to 50, which is stored in array B. When you want to compute the combination A of 1 plus B of 1, A of 2 plus B of 2, up to A of 50 plus B of 50. When you have to do certain operations of this sort, then you can certainly go for vector processing. How does it happen? What it does is C of 1 of 50 will be equal to A of 1 of 50 plus B of 1 of 50. This is how a vector processing works. This is put in a very, very simpler format for you to completely have a clear picture of how a vector processing works. All right. So the starting address of the two source operands and one destination operand and the length of the vectors, all these comprise of your vector instruction. I would just give you the format. All right. You have the opcode. Okay. This is in a very lower level format. What is an opcode? The operation code. Say, for example, you're going to add. The base is A of 1. Okay, the base address, the next one is B of 1. The destination is C of 1. What is the length? It has to go on till 50. So A of 1 plus B of 1 will be stored in C of 1. A of 2 plus B of 2 will be stored in C of 2. And it goes on till the length. What is the length we have given? 50. That's how it works. All right. So what are the features of it? So now that we have understood the working, what are the features of a vector processing? As you could have realized that by now, it does simultaneous operations. I am not waiting for A of 1 and then B of 1 to add. Once it gets over, I am not going with A of 2 plus B of 2. No, I am not doing that way. I am parallelly doing A of 1, B of 1, A of 2, B of 2. All 50 will happen in a single clock cycle rather than doing it in 50 clock cycles. All right. So obviously simultaneous operations are there and you need a special hardware for that. And second thing, it is a high performance. Anything that it could have finished in 50 cycles, I'm able to complete it in a single cycle. So it is high performance. So today I might be adding only 50 numbers. Tomorrow I may add 100 numbers. That is also possible. The 100 could be scaled to 1,000. The thousands could be scaled to 10,000, millions, billions. It can keep on adding numbers, but without compromising on the performance. That's why I call this vector processing, one of its features, to be highly scalable. Now, so there are only certain instructions which can be performed. So obviously those limited instructions which I am performing are completely optimized so that it performs a great amount of, it gives me a great amount of computational speed. And one feature of a vector processing is data alignment. As I told you, A of 1 can be added only with B of 1. A of 2 can be added only with B of 2. All right, so that kind of an alignment of data is required if you want to perform vector processing. All right, later on, I think we have already seen type of vector processing. This again, we have learned it in Flyn's taxonomy. We have single instruction, multiple data stream, and multiple instruction and multiple data stream. Here, I would expect you to write down what is SIMD, what is MIMD, the diagram, and then the explanation for the diagram, which we have already learned under Flyn's taxonomy, which we have learned under the architectural scheme variety of classification. All right, now let us look into the advantages of vector processing. These are all known features. I don't have to spend time on performing something. It is an increased performance and there is an energy efficiency. There is lesser access to the memory. It is scalable. Whatever we saw as the features, few of them will fall under advantages and few of them will fall under disadvantages. And it is scalable, numerical operations are completely optimized. All these are the advantages of your vector processing. Again, on the downside, I told you that there is a requirement for my data to be aligned only then, because I can perform A of 1, B of 1, A of 2, B of 2. I cannot be doing A of 1 and A of 10. If I have, sorry, B of 10. If I have to do A of 1 and B of 10, then B of 10 should now occupy the space of B of 1. Such kind of data adjustments and alignments are required, which is the biggest disadvantage. And there are not all softwares which are available to support the execution of vector processing. So there is a limitation with respect to software support, and it is quite expensive because you need specialized hardware to perform all these operations. And since it is majorly restricted to numerical operations, the applications are not very wide. It is limited to certain units where it involves arithmetic logic units. So these are the major disadvantages of your vector processing. So that comes to the end of the lecture. So what have we seen in this vector processing? We saw what is vector processing, how a vector processing is becoming a part of parallel processing, how does the vector processing work, how does the instruction format look, what are the various features of vector processing, what are the advantages of vector processing, and what are the disadvantages of vector processing. I hope all of you are able to recollect this. I wish that you write it down all these points along with the types of vector processing where we learned SIMD and MIMD. Write down all those points and then revise these. Thank you all of you for your patience.